In this video, I am going to share 8 solid reasons why I finally decide to switch from PowerShape to SolidWorks. You can change the audio track as per your language from setting below. Number 1. Sketch and sketch constraints. Before you start sketching in PowerShape, you need to decide the exact size of your geometry. Why? Because if you try to change dimensions later, your sketch might get completely messed up. For example, let's say I want to draw a rectangle that's 150 into 100 mm. In PowerShape, I have to type 150 space 100 in the command box for drawing it. But if I later decide to change only the width, you will notice that just one line extends. The whole rectangle does not adjust proportionally. Now compare this with SolidWorks, a completely different story. In SolidWorks, you can draw a rectangle freely and then use smart dimension to set the size whenever you want. The shape updates smoothly without breaking the sketch. Let's say you first made it 160 into 80 mm and then change it to 150 into 100. SolidWorks handles it with no problem. Here is another example. In PowerShape, if you want to create a circle tangent to a line, you first have to draw a line equal to the radius. Place the circle at the endpoint, then set the diameter. It's a long manual process. But in SolidWorks, just select the line and the circle by pressing Ctrl, choose tangent, and boom. Now you can easily set the diameter right after. Let's take one more scenario. You want to draw a horizontal and a vertical line, but your sketch turns out tilted. In PowerShape, you will either have to delete and redraw the lines or manually set the angle to 0 and 90 degree and then realign the endpoints. In SolidWorks, just select the line and apply the horizontal and vertical relation from the pop-up, and sketch auto adjust without disturbing the endpoints. That's the power of sketch constraints. Something SolidWorks gives you right out of the box, but PowerShape does not. Finally, imagine you have made a complex sketch and want to change one dimension. In PowerShape, changing it can disconnect the line from the rest of the sketch, and you will have to manually fix the endpoints again. Super frustrating. But in SolidWorks, Smart Dimension keeps everything connected, just 2 to 3 clicks, and your sketch is fully defined, accurate, and stable. Number 2. Feature tree and editor. Let's suppose you have placed a rectangle and extrude it in PowerShape. Now later on, you decide to change its dimensions. Well, that's where the problem begins. If you are using PowerShape, you cannot really do this easily. Now, I know some of you might jump into the comments and say, hey, that's not true. There is a way to do it. Yes, technically, there is a method, but I am not going to share it with you because honestly, it's so complicated. You would probably say, bro, just leave it. It's not worth it. Now, let's head over to SolidWorks and see how it handles this. You simply draw a rectangle, extrude it, and that's it. Even if you want to change its dimensions months later, no problem. You can easily do it within few clicks. That's the beauty of SolidWorks. All you have to do is click on the feature, choose Edit Sketch, change the dimension, and boom, your model updates instantly. Why is this possible in SolidWorks? Because SolidWorks gives you a feature tree which keeps track of everything. PowerShape on other hand does not have that, which makes edit a real pain. So if you have switched from PowerShape to SolidWorks, you are going to love how flexible it is. Number 3. Assembly of parts. Assembling 3D parts is as essential for a mechanical engineer or technician as having an air conditioner at home during this summer heat. And since it's already hot outside, I am sure you know exactly what I mean. But unfortunately, when it comes to PowerShape, its assembly feature is so dull and so complicated. that honestly doing anything else feels better than trying to assemble parts in PowerShape. I am saying this from experience. Yes, I used to assemble 3D parts in PowerShape, but that was before I discovered SolidWorks. If you don't believe me, go check out this video where I explained how PowerShape handles assemblies, or rather how badly it handles them. Now let's talk about SolidWorks. The assembly module in SolidWorks is just another level, packed with amazing features. All you have to do is create a new assembly file, import parts, apply few assembly mates, and that's it. Your assembly is ready, all within just a few clicks. So if you are still struggling with assembly in PowerShape, maybe it's time to switch, because in SolidWorks life gets way easier. Number 4, manufacturing drawings. Creating a 3D model is not enough, because to get your model fabricated you need to provide 2D manufacturing drawings to the manufacturer. That's the only way your creativity and imagination can come to life in the real world. But here is the problem. If you only know how to use PowerShape for 2D drawings, I can say with full confidence that you won't be able to get the job done properly. Yes, I have actually shown how to create a 2D drawings in PowerShape in one of my videos, but honestly, I would never recommend learning it that way. The feature is just not practical or user friendly at all. Now let's talk about SolidWorks. If you want to stay ahead in this competitive field, this is the tool you need. In SolidWorks, it's super simple to generate 2D drawings directly from your 3D model. You can easily place your views, add detailed dimensions, and when you are done, you can export the drawing as PDF, DWG, or in multiple other formats. That's why I personally prefer SolidWorks for all my 2D drawing needs, and I strongly suggest you do the same. Number 5, sheet metal. In the world of engineering, sheet metal parts are everywhere. You will find them in almost every mechanical assembly. Now at first glance, these parts might look simple, but trust me, there is serious engineering behind manufacturing them. So let's talk PowerShape versus SolidWorks. And let me be very clear upfront, if you are planning to design sheet metal parts in PowerShape, just don't. PowerShape does not support sheet metal at all. No tools, no features, nothing. But here is where SolidWorks shines. It has an entire sheet metal module built specially for this purpose. You can design sheet metal parts, create flat patterns for development, and even plan die design, all within the same workspace. And yes, you can also generate 2D manufacturing drawings with bending details and developed sizes that are ready for fabrication. Honestly, this is the one of most powerful features in SolidWorks. And if you are interested in learning it, I have got you covered. Just click on this video where I walk you through the SolidWorks sheet metal module in details. Number 6, weldments. When it comes to welding and welded structures, let's be honest, engineering is incomplete without them. They are everywhere, in frames, sports, and machine bodies. But here is the bad news. PowerShape does not support weldments at all. There is no dedicated module, no tools, nothing to help you design a proper welded structure. Now let's switch over to SolidWorks, and this is where things get excited. SolidWorks has a fully featured weldment module. All you have to do is draw a 3D sketch, then with just a few clicks you can add structural member to build an entire weld frame. This module is clean, fast, and super powerful. And honestly, this is exactly why I prefer SolidWorks. It makes complex structural design so easy and efficient. Number 7, rendering. After 3D modeling, the next big step is 3D rendering, a powerful process where you visualize what your product will actually look like once it's manufactured. But there is the thing, if you are still stuck with PowerShape, let me honest, you cannot do proper rendering in it. It simply does not offer any rendering tools or modules. To bring your design to life with realistic graphics, you need a more advanced tool like SolidWorks. SolidWorks comes with a dedicated rendering module where you can apply appearance, adjust lighting, materials, and create stunning product visuals. If you are not sure how to render in SolidWorks, I have made a complete step-by-step tutorial from basic to advanced, so you can start creating professional product renderings today. Just click on that video and see the magic happen. Number 8. Evaluate. Applying a material to a 3D part is not just about making it look good. It's also about understanding its real world physical and mechanical properties like mass, center of gravity, moment of inertia, and much more. But unfortunately, PowerShape does not offer any proper tool to analyze these properties directly. There is no way to truly evaluate how your part will perform. On the other hand, SolidWorks makes this incredibly easy. With just a few clicks, you can assign a material and instantly access a full breakdown of its physical behavior, want to evaluate dimension or run calculations. It's all built in, no extra steps needed. And that's exactly what made me switch from PowerShape to SolidWorks. Because when it comes to design analysis and real world accuracy, SolidWorks simply delivers.